So we're still working in 7.2, and this time, instead of being standard normal curves, we're going to be looking at some non-standard normal distributions, okay? So that means our mean is not going to be 0 when we're counting by 1. Our mean is going to be, whatever number we're used to, whatever the mean is for that particular set of data, if it's heights or IQs or whatever, okay? Now, remember, the process will be exactly the same. It's just that we aren't dealing with z-scores. So it's actually better. It's probably going to make more sense to you than the previous examples did, because it won't be a 0 in the middle. It'll be whatever the mean is for that particular data set, okay? The process is exactly the same. We're still going to pick normal CDF, give it the lower bound, the upper bound, the mean, and the standard deviation. Only the mean and the standard deviation won't be 0 and 1 anymore, because we're not doing standard normals, okay? So again, if they are giving you a cutoff score and you're looking for the area or the percentage of people that are in that region, it'll be normal CDF. If they're giving you the area and asking you to find the cutoff scores, then it will be inverse norm. So it'll be the same features on our calculator. Okay, let's look at an example. Women's heights are normally distributed. Now that's a big deal. They did not say it was standard normal. They just said normally distributed. Since they say normally distributed, that means it is appropriate for us to draw our normal curve. Okay? Now notice, my normal curve should get very close to the x-axis, but it should not touch. Okay? And mine looks a little bit maybe left skewed. I didn't mean for that to happen, but it should be a normal distribution. Okay, they tell us the mean is 63.6 inches, so right here in the middle is 63.6, and the standard deviation is 2.5. That means we're counting by 2.5s. So 63.6 plus 2.5 would be 66.1, plus another 2.5 would be 68.6, and so on. We could also count down by 2.5. 63.6 minus 2.5 puts us at 61.1. Minusing another 2.5 would put us at 58.6, and so on. Okay? So our mean was the 63.6. We're counting by 2.5s. They want us to find the probability that a randomly selected woman will be taller than 62. They want the probability that x is greater than 62. Okay? Well, where would 62 fall on our graph here? Well, 62 is below the mean. It's below the 63.6, but it's above that first standard deviation. So 62 is about right here. And they want to know the probability that the woman we randomly pick is above 62, that she's taller than 62 inches. So we want to know the probability that the woman we pick is in this region of the graph. I can tell by looking that it's going to be greater than 50%. 50% would be above the mean. We've got all of that plus a little bit more. So I know this is going to be more than 50%. I'm guessing maybe 65 or 70%, something like that. Okay? Since I know the cutoff and I'm looking for the area, that means I'm going to choose normal CDF. Okay? Normal CDF. I know the cutoff. I'm looking for the area. Area is what we don't know. Area is probability. Okay? Normal CDF, we give it the lower cutoff and the upper cutoff. Our lower cutoff will be 62. Our upper cutoff, our upper bound, would be infinity, but there's not an infinity button. So we're going to put 1E99 to represent 1 times 10 to the 99. We're going to give it our mean. Our mean is not 0. When we did standard normals, the mean was 0. Our mean is not 0 here. The mean is 63.6. And the standard deviation is not 1 because we're not doing standard normals. The standard deviation is 2.5. So in my calculator, second bars, normal CDF. My lower number, my lower bound is 62. My upper number would be infinity, but I don't have an infinity button. So 1E, remember to get to the E, you hit the blue second button and then the comma, and that will put in your E, 99. Okay, 1E99 means 1 times 10 to the 99th. That's a really, really, really big number. That's how our calculator will approximate infinity. The mean was 63.6. The standard deviation was 2.5. Remember, if you're using an 83, it will not prompt you for those items. You just have to know to put those items in that exact order with commas in between. When we type that in our calculator, we get 0.7389137, blah, 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 blah. Remember, we knew the cutoff. We were looking for the area, and area is rounded to 4 decimals. The 9 is our 4th decimal. The number after it is a 1, which is not going to send the 9 to round up. So 0.7389 is our answer. That means, okay, that there is a approximately 74% chance that any random woman we pick will be taller than 62 inches. It also means that approximately 74% of all women are above 62 inches. Okay, so remember there's 2 interpretations there. It's the probability of one person individually, or the probability or the percentage or proportion of all people that would be in that category. Okay, same mean and standard deviation, but this time they want us to know the probability, or want us to calculate the probability that the woman we pick is between 64 and 71 inches tall. Okay, well, again, our mean is 63.6. This time we want to, between 64 and 71. Notice that 64 will be just barely above 63.6. It's just barely above the mean. And then 71 will be a little bit further over here. There's 71. There's 64. So we want to know the probability that the woman we pick will be in this region. Okay? Again, we know the cutoffs. We know the lower and upper bounds. We know the cutoffs. What we're missing is the area. So that means we're going to use normal CDF. The lower number is 64. The upper bound is 71. The mean was 63.6, and the standard deviation was 2.5. That stayed the same. Second bars, normal CDF, fill in your numbers. And since we're looking for area, we know that's going to be 4 decimals. So 0.4349. The 9 will not round up because the number after it was not above 5, or was not 5 or higher. So this is the probability that a randomly selected woman will be between 64 and 71 inches tall. It's also the proportion of all women who are between 64 and 71 inches tall. Another example, the reading speed of 6th grade students is approximately normal. When they say approximately normal, they're telling us it's appropriate to draw the normal distribution. Again, do not let your curve touch the x-axis. It gets close, but it doesn't touch. The mean speed is 125. That means the average 6th grader is reading at 125 words a minute. And the standard deviation is 24. That means we can count by 24s. Okay? 125 plus 24 is 149. We could keep counting by 24s. Or I could subtract by 24s. 125 minus 24 is 101. I could subtract another 24. I'm at 77, and so on. Okay? What is the probability that a randomly selected 6th grade student reads less than 100 words per minute? Okay, well, where would 100 be? 101 is right here. 101 would be just barely below it. And they want to know the probability that that 6th grader reads less than 100. Less than 100 would be to the left. So we want the probability that x is less than 100. That's what they're asking us to find, written as an inequality. To calculate that, we know the cutoff. What we're missing is the area. So we are going to normal CDF. The lower bound would be way down here at negative infinity. We do not have an infinity button. So we'll say negative 1 E99. That means negative 1 times 10 to the 99th. That's a really, really, really small number. So negative infinity expresses negative 1 E99. Up to 100. 100 is our upper bound. The mean is 125, and the standard deviation is 24. Sorry, my writing got crammed right there. All right, so second bars, normal CDF, -1E99. Upper bound is 100. Mean is 125, and standard deviation is 24. Remember, if you're using an 83, it will not prompt you for those numbers. You just have to know to type them in and separate them with commas. And we get, remember this is an area, so we round to 4 decimals, 0.1488. Notice it's an 8 because the 7 is our 4th decimal. The number after it will is 5 or higher, causing us to round up. So 0.1488, which means that the probability that the randomly selected 6th grader we pick reads less than 100 words per minute is about 0.1488. That's about 15%. Or another interpretation is that the probability, the proportion of all 6th grade students who read below 100 words per minute is about 15%. Okay. Next example here. Here's going to be an inverse norm, okay? Remember, inverse norm means you give it the area or the percent or the probability, and it will give you the z-score. Or, in this case, it would give us the actual cutoff number since we aren't doing standard normals. All right, example. Women's heights are normally distributed with a mean of 63.6 and a standard deviation of 2.5. Same values we had a while ago. Okay. 63.6 here in the middle, we could count by 2.5s, okay? Suppose that a modeling agency will only accept the tallest 10% of women, okay? In other words, they only want the people that are way out here, the really tall people. They only want this group, okay, the really tall women. And in fact, they tell us that the top 10%, well, that means this area right here is 0.1 or 0.10. What is the cutoff height that the agency uses? In other words, what is this cutoff number right here? If I think that I should be a model and I call up a modeling agency and I say, hey, yes, I'm beautiful, I need to be one of your models, and they say, how tall are you? I'm going to have to tell them my height. And if I'm not above this number, they're going to be like, nah, sorry, not interested. So what is that cutoff number that they suddenly are going to be, yeah, we're interested in you. Send us some pictures, okay? We know the area, we're looking for the cutoff. That means we are going to inverse norm. When we inverse norm, it wants the area to the left. It wants us to give this value. Well, if the area to the right is 0.1, 1 minus 0.1 is 0.9. That means this area down here is 0.9. The area to the left of our cutoff is 0.9. The mean is still 63.6, and our standard deviation is 2.5. Okay? All right, so in my calculator, second bars, inverse norm. I tell it my area is 0.9, the mean is 63.6, and the standard deviation is 2.5. Remember, if you have an 83, it won't prompt you for that. You just have to know to type those numbers in. What should we round to? Well, remember, we had the area. We were looking for the cutoff. Now, the cutoff in this case is not a z-score, but we still round to 2 decimals. So 66.8. Actually, we should probably round to whatever place they were rounding here. Since the mean and standard deviation was rounded to 10th place, we'll round to 10th place as well. So 66.8. Now notice 66.8 inches tall is a reasonable cutoff because our mean was 63.6. We expect it to be tall women that they're interested in. In fact, you got to be 66.8 inches tall to be in for the cutoff for that top 10%. By the way, that's like 5'6", or almost, 5'6.8 inches, almost 5'9" inches before they would be interested in you. Okay. Okay, number 9. Reading speed of 6th grade students is approximately normal with a mean speed of 125 words per minute and a standard deviation of 24. Same values we had a while ago. 125 in the middle, we could count by 24s. A school psychologist wants to determine the reading rates for unusual students, both slow and fast. So she wants to know a cutoff down here for students that are unusually slow and a cutoff up here for students that are unusually fast. Determine the reading rates of the middle 95% of all 6th grade students. Okay, now 95% is a lot. That's almost everyone. So she's probably going pretty far out here on either end if she wants this area in the middle to be 0.95. Okay, 95% of the decimal is 0.95. Okay, so we are looking for these cutoffs. Well, 1 minus 0.95 is 0.05. But that 0.05 has to be split between the two regions. So 0.025 is the area of this region down here and this region up here at the top. Notice if I added those up, 0.025 plus 0.95 plus 0.025 does, oops, oh, I missed the 9, didn't I? 0.025 plus 0.95 plus 0.025 adds up to one whole, okay? So we are looking for these cutoff numbers. We're going to have to find two different ones. So we are going to find the lower cutoff. We're going to inverse norm. Okay. What is the area to the left? 0.025 with a mean of 125 and a standard deviation of 24. Mean of 125, standard deviation 24. Oops, I typed 25 right there, so 24. Sorry about that. So 77.96. Okay. And then the upper one, well, we've got 0.025 below and 0.95. So 0.025 plus 0.95 is 0.975. 0.975 is the area below this cutoff. Mean is 125, standard deviation is 24. And 172.04 would be that cutoff. So notice the average 6th grader reads 125 words per minute. The school psychologist is not concerned if people are lower than that or higher than that until you get to kind of the extremes. Okay? So 77.96 would be her cutoff. Anyone below that she's concerned about, maybe they need some special services. 172.04 is the upper cutoff. If anyone's above that, she's concerned about them. They may also need some special services. Okay? Now notice what's interesting about that to me is 95%. That leaves 5% out here. Remember, 5% is what we've always considered to be unusual as a rule of thumb. So these are the 5% that are unusual, and she's concerned about them and wants to get them some extra services. Okay? IQ scores is one way of measuring people's intelligence. IQ, actually, you know what? We're going to split that up. It's getting long. We'll do another video for the last few problems. Good job, guys.